So in this video, we're going to talk about run length encoding, also known as RLE, and this is a form of compression. Now, run length encoding is a good way to compress data which has lots of repeating characters or lots of repeating data. If you use run length encoding on data which doesn't have lots of repeating characters, then it can actually make the file size bigger, so thus making the whole point of compression irrelevant. So what we're going to do in this kind of section is talk about answering a run length encoding style question where we have to convert a string into run length encoding, and then also answer some of the questions which talk about just generally what is run length encoding and how does it work. So run length encoding is a method where we have repeating data. So let's imagine, for example, we have this string of data. So we have, like, say, 5 A's, maybe 3 B's and 2 C's, like so. This set of data is perfect for run length encoding, and the reason for that is because we have these characters which are repeated. So these could be pixels, they could be binary values. We don't need, the context isn't relevant, but the process is always the same. So how it works is the system, or when you compress it, it actually counts up the number of runs that are in a sequence. So for example, here we have 5 A's in a row. So how you represent that is you first put down the number of times that character appears sequentially in a row, which in this case is 5, and then you follow it by the character code that it's referring to. So there are 5 A's, like so. Then we move on to when it changes, we then move on to the next character, which in this case is B, and I count 1, 2, 3. There are 3 B's, so that becomes 3B. And then finally, the next run is C. There are 2 C's, so that becomes 2C. It's important to note with these questions that let's imagine we have A, B, B here, like so. You don't count up the total number of A's, so it doesn't become 6A and then 5B. It actually carries on. So when this run ends, it goes to here. There's 1A, so that becomes 1A. And then obviously we've got 2 B's there, so that becomes 2B. So by doing it this method, we've actually saved ourselves a number of bits, because if we count the full string, we've got 5, 6, 7, 8, 9, 10, 11, 12, 13 characters in this string. Whereas in this one, we have 2, 4, 6, 8, 10. So although it's not a massive saving, we've actually saved ourselves 3 bits, which is what the whole point of compression, to make something a little bit smaller. And then obviously when this is ran, the computer just rebuilds the codes and puts them together. Like I said, if it's like A, B, A, B, A, B, A, B, you'll actually find that you end up with more bits than you originally had, therefore making it not very useful for that method. So let's have a look at a past paper question. So it's very similar to the method we just did then. So we've got TT, JJ, and then 3 E's and then 2 S's. So all you do is you start at the beginning of the run and go, right, T and T are together until the run ends there. So that is 2T. Then we have 2 J's, so we write down 2J. Now we have 3 E's in a row. That's the next set of runs. So 3E, and then finally we have 2 S's at the end. And there we go. So this is worth 2 marks. So you'd normally get marks for kind of half correct and the other half correct in this example here. There you go, it's that simple. That's all you need to do on these types of questions. So the more theory style questions then, talk about like what is run length encoding and like how does it work. This question kind of has a bit of both. So this first question, state the feature of data that allows it to be compressed effectively using run length encoding. The answer to this is that it must contain lots of runs. Or, alternatively, you can also write has repeating values. As we looked at here, okay, this data here has lots of runs. This is a run, A to A, B to B is a run, C to C is a run, and so on, okay? Whereas if we had this string here, like so, that does not contain multiple runs or repeating values, therefore, that feature is not relevant. So for run length encoding to be useful, it has to have repeating values or contain lots of runs. This next question, describe how run length encoding works. So you get a few marks for this one. This one says you must use an example as well. So what you're looking for is the number of consecutive, let's just spell check that. Consecutive values or pixels, whatever you're talking about in the question here, need to be counted. So that says that. So these values are counted. So A counted, say, 5 times. And there you go. So that's basically what happens. It's counted. And then to give an example, you can just use an example like I used before. So I could just say something along the lines of the string AAAA BBBCCC would become 4A 3B 3C, like so. Okay, so the key to this one is explaining that the number of consecutive values or pixels are counted, and then you can give an example, and this is one here of how how it's built up. We did it here, and there you go, guys. So that's how you answer run length encoding questions on this exam paper.